This problem gives us a graph up above. The graph of the function f is shown above. And so that's the first thing to note is what graph are you looking at? That's a huge piece of any graphing problem. So this graph is the original function f of x, and they want us to know on the interval they're giving us here from 0 to 4, so from there to there, which of the following has the least value? So we're looking for the one that is the smallest amount. If you take a quick glance through this thing, what you real fast find is that you're going to be looking at basically a Riemann sum problem, right? Like all of these are Riemann sums, Riemann sums, Riemann, Riemann. And the only thing that changes really between any of them is what type of Riemann sum, whether we're talking left, right, midpoint, or trapezoidal Riemann sum. And then the first one here, this is the actual antiderivative, right? So Riemann sums are always going to give us an estimate, and the integral itself, right, is going to give us the actual value, like the real value. So the odds of A being the right answer are pretty slim in a situation like that. But what you would say is it's the full area between 0 and 4 right here, basically filling in all of that shape. So if that's what ends up being the answer, I would be surprised, but let's go through the rest of these. So we're doing left-hand Riemann sums, or right-hand or whatever. Notice that all of them have the same 5 subintervals as you go through this. So if you wanted to, you could quickly sort of divide this thing up into 5 subintervals. To do that, you would say you find your delta x, which is the max of your interval, minus the min, divided by the number of intervals or the number of rectangles. So in this one, the max of our interval is 4 minus a min of 0, and divide that by the number of subintervals, which would be 5. So we're basically moving over 4/5 every time. So you would start here, this would be 4/5. You don't need to be accurate with this. You're just kind of trying to give yourself a quick little number line to play around with. So then I put another one in there, that would be 8/5. I put another one in there, that's going to be 12/5. I put another one in there, and that's going to get me, 16/5. And then I put another one in there, that would get me 20/5, and that would get me right to here. So those are the end points of all of my intervals. And this is just an approximation, right? So from there, I kind of eyeball what I'm looking at. So the first one wants me to find left-hand Riemann sums. So starting on the left of every interval, we'll call that A1, A2. I like to label the gaps, so I just keep track of which one I'm looking at the left or the right of. So on A1, the left end point would be over on this side of the interval. So drawing up from there and then drawing over from where you hit the graph, and then you draw back down. So that would be area 1. And when I'm looking at these things, right, I'm just trying to get a sense of what would happen here. And I can see from my drawing that what I would get out on this would be a bit of an overestimate. So I'm going to be getting more than what the actual area would be. And we don't need to draw all of them because all of them are going to look the same because the shape of the graph is the same. So right there, that's a left-hand sum. And I say, okay, a left-hand sum looks like an overestimate. Next one says go do a right-hand sum. So moving over to A2 now, if I use the right end point of A2, that would be this point right here. And so from there, I draw up until I hit my graph. And then again, I cover up my interval. And so this would be A2. And what I can see on A2 is I'm missing a whole bunch. This would be an underestimate in that situation. And so that's looking pretty good right now because I'm looking for the smallest value. I know it's definitely not the left sum compared to that, and I now can say clearly it's not the actual value because I'm for sure getting something smaller than the actual value. I go on to my next one. My next one after that is going to be the midpoint sum. So that means I come into my interval, A3 here, and I would be drawing from the middle of that interval. So again, process-wise, I draw up till I hit my graph, and then because it's the middle, I would have to draw a little bit this way and a little bit that way. And so while we can see that we would have some underestimate on this side, we're going to have some overestimate on that side. So those two things are going to essentially cancel each other out a little bit. And so you're going to end up again with something that's probably a bit smaller, but it's definitely not as much of an underestimate. And so I would say the midpoint is not as small as my right-hand sum. And then the last one on the list is the trapezoidal sum, which is everybody's favorite one, right? So that's where you're taking the two sides of your area, and you're sort of connecting. That would be the bottom, and you're kind of connecting 2 points on your graph. So on A4, for my trapezoidal, I would be hitting here, and I would also be hitting here, the two sides of that interval, and I'd be connecting along that line right there. And as you can see from drawing that, that's pretty accurate. Whatever under or overestimate right there isn't going to be very much, and so I would throw out the trapezoidal sum as I come through that one. And after going through all of those, I would say very clearly my right-hand Riemann sum is going to be the smallest because it's going to be giving me an underestimate with every rectangle I draw. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.